Morning, everybody. And you actually spoiled a few slides of mine, so that doesn't matter, but it's fine, it makes things easier. First of all, I've suffered a little by coughing, so in case I scream at you, coughing into the microphone, I do my best to cover it away, but in case, close your ears, that's maybe better. So, thanks for having me and inviting me. I think this is a pretty interesting talk that I will give you now, because it has nothing to do with corporates, and I will try to go a little into tech, but try to tell you how a startup thinks from its very beginning. As I was there from the very early days, I saw everything, all the phases we went through and so forth. Blinkist nowadays is a startup, venture capital based, with 70 employees from 30 nations. So we have, and this I think is also special, we have a split of men and women of 50-50%. And we are only a little developer and engineers team. And we're operating worldwide. So 70 employees, I think 15 engineers in total operating worldwide. And the Blinkist product, what it does for you is actually bringing you the non-fiction books. That means you have tons of books in your bookshelf that you always wanted to read, Lean Startup, LeanIX, whatever. There are tons of amazing books, and you don't have the time to read them. That's why we thought we'd bring them onto your mobile application, mobile phone, that you can read them in 15 minutes. And we have people that also record them so that you can listen to them while you, I don't know, have a run. Suits Adidas theme here. And since a while, we're also on Google Home and Amazon Alexa. So I am referring to the vision of Blinkist here and how microservices helped us there. And big ideas in small packages is actually referring to our companies, our products idea, big ideas of non-fiction book put into small packages. And I find that that pretty suitable for the term of microservices, because you put a lot of good things into tiny packages. The Blinkist vision is split into two parts. The first one is the business vision. Obviously, we wanted to create our own company that works with our most internal values, with shared, with a lot of transparency, shared ownership, and so forth. And the second part is obviously the product vision. So we want to inspire people to keep learning. And we talked already about the product. This is basically how it looks like. We mentioned it a few times. We have an app on iOS and Android that you then can read all our books in. We have 2,000, I think we're reaching 2,500 books. And the way a startup usually works is you have different phases you walk through. The first phase is from the funding, from you have that idea, you get some money. Our first investor was Hubraum, Deutsche Telekom. You think about the product. So first you have to figure out if anybody actually needs your product. No, that's obvious. You don't know. You don't have a market. There is nothing. Startups tend to go into a business area that is not yet filled by anyone else. So we did that from 2012 to 2015. And you will see throughout my presentation that I walk you through how we moved in the back end from these early days into where we are at now. And the second part is that you need to scale the business then. You have your product market fit, people are paying for it, now you want to scale it worldwide and earn millions and millions of money and become the world leader in anything you can think of. What you will get out of this little presentation next to the history of how the backend of Blinkist evolved is our 4 mantras that we came up while we built this backend system of Blinkist that we say out loud every time we make an architectural decision. It's similar to the values we saw from Adidas or what Peter mentioned from SAP, that our key learnings and our mantras. So let's check how we validated the product and how the backend looked. I will go a bit more into tech, but I hope, Julia, you also understand that. I try to keep it simple. That's up to you, that's true. So when we wanted to validate a product, we had only little resources. It was actually 2 backend engineers. One was me, and the other one was a junior Ruby on Rails developer. We are a Ruby company. I don't know how many enterprises are using Ruby, but we do. We're not an enterprise anyways. And what we had in front of us was a requirement catalog in the first day of Blinkist from the product manager, one of the co-founders, with 70 features. He wanted to have 70 features, a map, and it should be visual, it should move, and it should be a mobile application and a website, 70 features, so we expected this product to change over the time like million times. So we needed to be able to adopt to this high change rate in the product. And this was another big issue. We hoped for the big bang. So iTunes talks about Blinkist. Some, I don't know, Times.com talks about Blinkist. What happens then is, and we had that, the usage increased like by 1000% overnight while you're asleep, because it mostly happens in the US. So you also have to prepare for that big bang, surprising success of your product. And the way we approached it was naive. I came from university back in the days, and we said, well, we need to have like this mobile application. It talks to an API. We need a little admin tool to, to deal with the content. We need someone to write the books in, and it's a shared database. It's MongoDB. That's technical detail, doesn't matter. And the way I learned it in university to set that up is simple three-tier architecture. Obviously, not a big deal. You have a little view controller on top, and then the main invention we did was to go for like this shared core logic. Peter said as well from SAP, they have the core. I think every company has a core. Someone said they have a reactor. So every company seems to have like this core functionality. And we built that in a way that it is reusable throughout other applications, because we anticipated, or we saw already like this admin tool, this API, they should share the same core logic. So we put that in. Interestingly, it also has a database driver inside, because that was just more convenient for us. The backend was actually running on Heroku, which is a platform as a service provider. You just push your code, and they somehow know how to run Ruby, they somehow know how to run Java apps, they somehow know how to run PHP. We did not know a thing. We were not interested in infrastructure because this was not in our business focus. We wanted to build a product and not a tech company. So that is the simple reason why we went for that. The cool thing about this architecture that you see here is, thanks to this shared core, we were able to add new applications like really easily. And what happened is the product management came and said, well, we want to have a website, a web app where people can log in and read their books there. And obviously what we did was just like adding an application. And this was really a matter of a week, and we had a website with everything inside. Books, all the share logic, authentication, and what's or not. That was really, really easy to deploy. And we saw that this architecture basically scaled amazingly. So we figured out another issue that was not coming from product management, but what we did naively, because, young startup, you signed up on our API or on the website, and there was someone starting to do something like CRM and said, we'd like to have a newsletter. We'd like to have a newsletter set up. So we checked out, there was a vendor for that called MailChimp. And during the sign up on the API with the synchronous call, we also signed you up on MailChimp. Don't do that. Julia, that's an important message here. Because what happened, during the sign up, MailChimp was not available. Sign up did not work. So we came up with the fantastic idea of, let's process some tasks maybe in the background. And we said, no problemo, because we have that shared database. Let's put events into that database and just poll that table or collection, how it's called, every second, and see if there are new events that we can process. And as you can see, it was pretty simple. This SaaS, software as a service provider, was MailChimp. This newsletter system was the first functionality that we then shipped over to this asynchronous processor. Later, we also did some BI, obviously, with this async processor. It was pretty easy to set up. And our software architecture looked fantastic. Now we have this shared core functionality, it's cool, connecting to the database, having everything inside, just a view layer, but really slim on top. And I know you're all architects, and you might wonder, if that scaled, and yes, it did, I'm not kidding, thanks to Heroku, you have a drag and drop slider to increase the service instances of each of these apps. So what happened, we got a feature on iTunes, and the day before we went to sleep, we just increased the slider to, I don't know, 4 instances instead of 2. So we doubled our resources by just dragging the slider, paid $50 more a month, that was it. So the product got validated, and I'm not kidding, we created revenue with exactly the setup, got our first users, our first customers were happy, we iterated over the mobile application, and everything was really, really cool. We created these nice monoliths, and so forth. Now looking at scaling the business is you have your product market fit, and now you want to get the hockey stick that every startup book is talking about, and every investor loves to see. And we knew that the requirements would change a little. And the requirements would be that not only the user count changes, but also the employee count changes. So since that time, we doubled our team every year. What happens if you generate every month a bunch of new stakeholders, like the CRM girl turned into a CRM team, the product owner was the co-founder turned to a product team. So everybody they were like this team and that team popping up. And we said, all right, most likely the product will not change that much anymore because we were pretty confident that this is exactly what we want to sell now. But tools around will pop up. Like everybody wants to have this tool or that tool or I don't know what, you know more, like the slide that SAP showed. These systems, I mean, they come from feature requests internally, I assume. So we expected this to happen. And our load will increase dramatically. Like hockey stick means user go up, revenue goes up, also load goes up like crazy. And we started with validating the business vision from 2015 on, more or less. That is not like a hard cut. You don't sit there the other day and say like, all right, let's scale the business now. But this was more or less this timeline, just to bring it up. And what we ask ourselves from tech, like these 2 people we were back in the days, will our approach scale actually? And we looked at the data, and we saw that Blinkist already grew until that point that we checked it. But that is not the user count. This is the lines of code in this shared core. I saw like another 0 or 2 more zeros at the SAP slides. But this is for a little startup with 2 engineers, already quite a code base, I'd say. And the reason why that happened was, obviously, we started with having content, categories, books, whatever, images, audio, chapters, everything you can think of, library management, you can add the stuff to your library and read it, retrack your reading progress, authentication, and so forth. And then payment after a while, and then marketing tool and CRM, and here and there, premium features. And we were thinking, is that going to be the future of our software architecture? And this core will just grow and grow and grow and grow. That was one problem, like the size, only the size. And what we then realized, I mean, we were aware of that all the time, but then it really started to hurt, is that we created like these lovely monoliths that in the end have an enormous high coupling to the database, to each other. Like when you changed one feature and you rolled out one tiny feature, let's say you change the field on a title, just remove it, no? And you roll out the API and you check it, works fine, amazing. Like a month later, you add another feature that you need in the web app and you roll out the web app, but you forgot to adopt to that feature, boom, crash. Web app offline. The same thing happened when someone by coincidence deleted like a collection from the Mongo database because we're a startup, we're lean, everybody had full right access to the database. Suddenly, all these systems were offline. And like these are just a few facts that you might see that we were sure that this will not scale. And what we thought then was we need to have certain rules. We called it rules, or in our world we call it mantra. So we came up with a few mantras. And the first mantra we set, because we read a lot about it, like the amazing books about microservices and so forth, we said that all new features we will build into microservices. So we don't touch the old crap, but the new stuff, please, let's bring it into microservices. And I guess there are many reasons why you should go for microservices. The ones that I like the most is actually that it's designed for failure. Everything that was hidden inside our monolith becomes explicit. You know, if you have a network timeout, handle it. That's the first rule. When you do microservice, expect the other system to be offline. Live with that. The other thing is you have instant feedback. So microservice architecture does not reflect only to how do I structure my application. It's also about the organization around it. That means instant feedback. Microservices, if you look at Martin Fowler's website, says instant feedback comes by constant delivery. So every time we push something to develop or master, boom, it goes live. We had a nice discussion yesterday at the dinner about releases. And I said, well, we don't have releases. We release, I don't know, 20 times a day. I don't know what a release would be in this case. So all these things, and there are way more points and pros and cons on microservices, and want to talk about them. This was our first mantra. So, and it did not take long, obviously, that product management came again and said, hey, we want to do A/B testing because we want to check how the onboarding experience is in a control versus a test group. So A/B testing is a pretty simple thing. You sign up and you roll the dice, and then you decide, do you go into the control group or into the test group? And then you measure the data in the background, like how many signups did the control group create and how many did the test group create, and then you are data-driven in decision making. It's not, I think that the blue button is nicer than the green one. That's why we should go for the blue because I'm the CEO. No, we said, well, let's run an A/B test on that. And so that is like the business background of this feature. But what we decided on was we built now a reference architecture for how microservices should look like for us. With that tiny little feature, it's really not doing a lot. And the fundamental requirements we said we wanted to have is we still want to focus on the functionality. We don't want to become a tech company. We're not selling any tech functionality to anyone else. So we wanted to focus on our business. And it should be scalable and replicable the way we had it before. Like we want to reuse that. Adidas said this morning that reuses in focus, and it's the same for us. And we wanted to have the developers onboarding really low level. So new developer comes and it's easy to understand what's happening anywhere in our architecture. And we said to do that, we need to go for tools and standards, which brings us to our second mantra, which is the more standards, the better. I find it very confirming that the talks before said similar things. Standardize certain aspects of your IT infrastructure or your corporation, and everything will become faster because you don't need to think of whatever. And if you think about a microservice, the first thing what we thought of was the communication aspect. And we thought that the best way to do microservices is using the web technology stack. And this is why we did not integrate any enterprise architecture, bus system, or like a queuing system, whatsoever. We just go for stupid, simple HTTP protocol with some JSON on top of it. And as we wanted to go for a JSON API, we said also this should be a standard. There's so many applications out there, so many vendors that have like this JSON format, you know, sometimes called link, sometimes called URL, sometimes called target, just to mention a few items that are semantically the same, but the syntax is just different throughout every system out there. And we found JSON API. JSON API, I don't want to go into the details, but it's basically defining all these flows, like how do you create a resource, how do you ask for a resource, how are they set up, do they have relationships? If so, how are they exposed, and so forth. And I found a nice analogy, at least I like it. From university, I learned there is already a standard for APIs and web service, which is the so-called simple object access protocol. And for me, it's a bit like you want to fly a plane, and you know you have your ailerons and an engine maybe. That's it. But it looks a little like this, you know, like an Airbus A380 cockpit with a little knot here and an autopilot there and a circuit breaker there and a computer here, and it needs to have a satellite connection. And JSON API compared to that is a little like this. This, I don't know if you know, it's like the Icon A5. The designers of this plane had a car in their mind. They wanted to build a consumer product. And they said, well, how does a car look? Let's put a joystick in, done. You know, that's as simple as that. And you see, I'm really a lazy developer. I want to automate things. I don't want to think about it. I don't enjoy going deep technology and wonder how it should work. And that's why we said, let's use what we learned as a software architecture inside these microservices. We have a little RESTful API. We have a controller, model, ORM, SQL database, standard, no fancy document store or whatsoever, graph database. We did not really care. And we said, this is going to be a simple Rails application. Stop. That means standard as per tutorial. You look into rails.com, you see the tutorial, you see our code, you know what's happening. And that is why our Rails controllers, you don't need to read the code, it doesn't matter. But if you know, this is like the controller that deals with like an incoming segmentation of a session. This is really lean. We try to keep our functions around like 5 lines of code, you know, unit tested and so forth. And that helps us, we hope, to onboard our developers easily. Now, we need to add that to these monoliths because we wanted our own monoliths to connect with these new services because our API, for example, was the central entry point from our mobile applications. So we said it has to somehow reside and live in that monolithic application. And we created this microservice client. And JSON API has a nice advantage. It's offering 1 million libraries for all the programming languages in the world you can think of, thanks to standardization. And we took one of them, wrapped it into our own package, called it Blinkist Microservice Client, did some fancy pants feature addition, and support the open source community back with our findings and bug requests to the technology. And the thing is, it's actually looking like this. If you want to get like the first number of all the sessions on your remote service, you call that A/B tester session page 1, and then you can just iterate over them, loop over them. And the service client translates that into a URL call. And it's really just one line of code. And if you want to create one, easy as that. It follows the Rails paradigms completely. Internally, it has all the magic you need: circuit breaker pattern, retry, API versioning that you can fix it, tracing of requests, what's or not. And that really helped us a lot and helps us a lot today. The last part was the infrastructure. So we wanted to get off the Heroku thing. Because Heroku is nice, you have this lovely slider, but there's so many things you don't know. One example, this MailChimp, I talked about this asynchronous processor signing you up on MailChimp. They blocked us. At some time, all our requests got blocked. And I called them, say like, hey, we cannot contact you anymore. And they said, yeah, your IP address is spamming us. And I said, I don't have an IP address. I'm running on Heroku, you know? What is that IP address? And then I called Heroku and told me, yeah, one of their clients is actually running a lot of processes on that machine. You need to pay $1,000 a month to have a dedicated IP address that you can then talk to MailChimp to. And I said, all right, this has to change. We want to have the infrastructure more under our control. And to make it easy and simple, and spoiler, we went to AWS, who does not, and they offer a fantastic service which is actually like managed container cluster for Docker. The next standard, we wanted to go for Docker. Back in the days, there was nothing Dockerized. On Heroku, it's not necessary. For AWS, we had to. And some tech insights. This is how our architecture looks now. We have these monoliths on Heroku, and they talk regularly via the public web to an application load balancer that then delegates the request to the respective Docker instances. And these Docker instances, they run on an EC2 computing node, which somehow get linked to that cluster, and somehow, we really don't know, ECS puts the different instances on these computing nodes. We really don't know, and we really don't care. And they all talk to a Aurora database, which is a MySQL database on steroids. All this runs in like a VPC cluster, and was a really nice setup that we by the way, nearly forgot that it's a crucial thing. We wanted our architecture to be written as code as well. So what we did is we checked out what's on the market, we found Terraform, and we have a GitHub repository that contains everything to set this up. You know, you don't need to know anything, you don't need to know in which order to click what UI elements on the AWS website. We can set up a new data center in no time and link the accounts in no time because this is all scripted. There's certain like tests on top of that, and next step would be to also do that CI/CD, like a continuous deployment pipeline for our architecture, infrastructure. So this A/B tester got deployed in no time, and we wanted to check the performance of that, and it was pretty nice. What you see here, just point it out this time. On the right side, you see the throughput, pretty simple, requests per minute. And in the circle, you see milliseconds. Milliseconds is the response time of one request in average. That looked pretty nice, and we said, well, this is pretty stunning. Let's go and move our API just for fun. You know, Dockerize it, put it there. Not a big deal. And we benchmarked this against Heroku with a tool called Locust.io. That doesn't really matter. And what happened is our API scaled like magically. Like this was 15,000 requests per minute. And the response time was nearly not changing because this just scaled into eternity. We did the same on Heroku. We increased the dynos, like in our feature that we had, and it looked like this. No? At 3,000 requests, boom, stop, crash. The whole application crashed. Nothing was working anymore, which brought us to the simple conclusion that we should maybe move all our monoliths over. And the moment we did that, it's also nice. I like recorded it because I liked it so much. The Heroku performance was on average a little bumpy, so sometimes 100, 300 milliseconds, something like that. And then we turned it off. You see the throughput goes like whoop, down. And on AWS, the same code, the same database, everything the same, was like flat. 50 milliseconds, like no bump, nothing. We were completely impressed. So when we look at this, what does that actually mean in sense of scaling? We wanted to scale our company. That means we take the product, we evaluate it via the monolith, and bring it up to the masses. First of all, we didn't expect to move the monoliths that quickly over, but this helped and saved our ass, I have to say, because we got another feature, and this API was just suddenly scaling, and we didn't even recognize it. We did not get an alert, nothing. That was really cool. We have now a setup for microservices that comes at no cost. We add new microservices as they're boilerplate code. You run a code, it downloads the boilerplate, boom, chuck, deploys it to AWS, all in there. And if we see how that operates together with the monolith and compare the features that we built into the monolith, although we did not explicitly say that, we did a feature freeze in this core and added a pile of new functionalities to these microservices. And currently it looks like this. It's a little more similar, but a little more detailed. We now have our monoliths. These are the red guys. On the left, they're still connected to the application load balancer. And internally, they have a connection to our microservices. You see ... means there are a few more. Was just not too nice to put them there. And there's this Aurora database. Now, the Mongo database also residing on AWS as a shared service. Obviously, we don't want to operate that. And this asynchronous worker is also built with a tool from AWS called SQS, Simple Queuing System. And compared to SOAP, this is really simple. And so this messenger, for example, you want to send an email, you send a post request to that service and queues it. The messenger worker gets notified and then, boom, puts it out via email. The API itself today looks like this. We have now 6,000 requests per minute instead of 2 before the migration. And you see there's a tiny spike. I'm happy that I captured it. Like this tiny spike over there, it goes up to 12,000 requests. That was a funny bug that our Android engineers deployed. Every time they got a push notification sent, they were calling the API. That wasn't there before. And the good thing is, usually you have a push notification, you open the app, and then you call the API. But on Android, you get a push notification, and the app starts in the background. No? And they didn't know that. We're a startup, you know, We don't know everything. So what happened is every hour when we send these push notifications, we started a distributed denial service attack against our own API with all our Android applications. This bug got fixed in the meanwhile, by the way. Let's talk about the learnings. I mean, I think you see we're like a small company, LeanIX. I think we're lean. You cannot be leaner than we are. Maybe naive is an alternative word for that. Hey, but we scale a business to like a proper million company worldwide, at least. So that speaks for us. But the biggest learning, the two biggest learning I want to share with you, besides tons of others, is maybe you realize that, but we haven't talked about monolith to microservice migrations. So I was adding these new features into this new infrastructure with new Rails and so forth, easy peasy. But there was this one guy called Content API that I briefly want to line out. This Content API is part of the domain that resides in the core, in this shared core. And what happened the other day, like, I don't know, a year ago in our magical scaling phase where we expected the product not to change, product management came and said, I want to have a new feature, and we call it minutes. Minutes is basically like an espresso of a book every day. So they wanted to send out a summary of the summary via email every day, so that you, when you open your mailbox in the morning, you have a quick read, get motivated, whatever, to read the book on Blinkist. Doesn't matter. So this is this product minutes, and we said, well, it's a new feature for the core domain content. And who remembers mantra number 1? Exactly. All new features will be built into a suitable monolith. What does that mean in this case? Damn it. Well, it was actually easy. Like, we create this new boilerplate, easy 1 hour of tasks to ship that service and have it up and running on ECS. But the moment we had the logic and the database structure there, we said, how are we going to do that? And this was the moment where we completely failed. Why did we fail? And I think this is what everybody who's an enterprise architect and has like 500 applications that needs to be consolidated, and you need tools like LeanIX and whatsoever to do that. We saw that already on a tiny scale, because with these 30,000 lines of code, we created an enormous coupling inside the code. So getting these books, chapters, audio, and categories out into like another service running on a computer with a network in between, like we thought, like, okay, let's take this one developer, as a side project, give a try, let's see how it rolls. Well, after 6 months, he gave up and said, like, fuck you, we cannot do it like this. So what we learned there is actually, that is a pretty tough thing, and you should not underestimate it. And we had a little retrospective and were wondering why we did not focus on that. And that was pretty simple. It was not necessary. And this brings me to the third mantra that we come up with. Only migrate existing features if it creates business value. So having that minute was adding business value. It was like increasing retention to our product. That means people opening our product every day in their tool, in an email, brought us in a lot of customers because they wanted to have that and they got sticky to the product. But this migration was like a self-fulfilling prophecy. If we had put the books out, it would be like a nice tech exercise or architectural exercise, but there was no need for that. So we came up with that other mantra. And the second learning, AWS. I know many people warned us. They said, like, don't go to AWS. This is a vendor lock-in. You will not be happy. What happens if they're offline? Whatever. And I said, this is AWS. I don't know if they're offline. Then the world is offline. Do I care? All right, they shut down this S3 service once. That was not so funny, but I think they also learned their lessons. They got instant feedback, like this microservice approach. But what we learned on AWS is the way Rails, Ruby on Rails. Many of you think this is a big framework, overhead, full whatever. We have 10 milliseconds response time on our core A/B tester. That is really fast nowadays. And we could focus on our functionality, our business. And that was the very same for AWS. They allow you to focus on your business because they offer you all the tools fully managed, and you don't have to think about them a second, because this just scales. And the cost you put in to manage and organize and run that stuff yourself was, for us, never outweighing, I don't know if this is a word, but like, you know what I mean. It was never worth doing it our own. And now we can have a nice sleep, you know, we don't care, everything scales, they have auto alerting, whatever, amazing. So we came up with the last mantra, number 4, which is embrace the vendor lock-in, but act wisely. So we actually rely on AWS, but we don't depend on them. We have everything as a Dockerized app. We take it, put it, for example, to Giant Swarm, like the next presentation. We wrapped all their SDKs simply with an adapter pattern away. So it doesn't matter if you use this email service or another email service, it doesn't really matter. So the vendor login, embrace it because it helps you to focus on your business. And to quickly recap what I was talking about now, we had these 2 phases. One was we need to scale the product vision. And I would always do that with a monolith. The reason why is changing things in a monolithic application is simple and easy. Everything is there, throw away that object, add this object, change it a little here. That went like, we had, I don't know, 60 different features and it ended up with 15, but that was really simple and came at no cost. And it actually created revenue. So without these monolithic applications that you all found funny, me as well, when I set up this presentation now, they created revenue and allowed us to like start a business. And Blinkist is a successful business. And it paved the way for the microservices. Now we are at a scale where we can say, nice, microservice. They scale our business up now with the right tools. We know that the infrastructure is better, the architecture is better. Now we have the time and money with a new feature that brings business value. We move pieces out. And then we have a stable company setup, sorry, an IT tech setup that then can go into eternity, and we can go for world reignship. You know, we can lead the world in our business. And that you see all the mantras again. I don't want to read them out loud, but if you forgot one or the other, just check them. And the only thing I can say is, and repeat myself, we started with looking, or I started this talk with big ideas in small packages, which reflects to our core product, but also to microservices, because these tools help us a lot to do really critical things, like this A/B testing is one of the core features that we have now, but they are not related to the product itself, for evaluation and transparency in the company. There are many other things that we use for BI and so forth. They help us for everything around the product. And the second part, the scaling, worked out. Blinkist's visions are scaling. The product vision and the business vision. So we see the product is used. By the way, we have enterprise subscriptions. If you're interested, later approach me. I have some vouchers if you want to try it out first. Nevertheless, we are a B2C focused company, and it worked out. I mean, we're approaching the 3 million users now, and that is a nice thing. So I believe microservices are amazing if you use them at the right moment, and I hope that I could give you a little sneak insight into how a startup rolls compared to a big corporate, and thanks for your attention.